Welcome to our Ethereum virtual machine tutorial series. In this series, we're going to build an intuition for how your smart contracts execute under the hood. We'll refer to the Ethereum virtual machine simply as EVM. So what is the EVM? Think of it as a global, decentralized computer. Every node in the Ethereum network runs its own copy of the EVM. When you deploy a smart contract, you're giving the EVM a set of instructions called bytecode. The EVM reads this bytecode and executes it. Every node executes your contract in exactly the same way. They all follow the same rules. When you write an Ethereum smart contract, you write it in Solidity or Yul. But the EVM doesn't directly understand your Solidity code. It understands bytecode. So how do we get from Solidity to bytecode? There are actually two ways. The first is the legacy pipeline. This is the default. Your Solidity code compiles directly into opcodes, which then become bytecode. Solidity to opcodes, the individual instructions that make up the bytecode, to bytecode. But there's a newer approach called the IR pipeline. IR stands for intermediate representation. With this pipeline, Solidity first compiles to the Yul assembly language. Yul is a low-level language that sits between Solidity and opcodes. Then, Yul uses opcode syntax that directly maps to the opcodes in hexadecimal. The opcodes are compiled to become bytecode. You enable this with the via IR flag. In this series, we'll look at Yul a lot. Since it maps closely to the actual opcodes, it helps us understand what the EVM is really doing. Now, you can't talk about the EVM without talking about gas. In the real world, you need gas to run a car. In Ethereum, you need gas to run a smart contract. Every operation the EVM performs costs gas. A simple addition, 3 gas. A multiplication, 5 gas. But storing data to the blockchain, 20,000 gas. So why does gas exist? Imagine if someone wrote a smart contract with an infinite loop. Without gas, it would run forever, bringing the entire network to a halt. Gas prevents this. You have to pay for the computational resources you use. If you run out of gas, the execution stops. This protects the network from abuse. Let's look at a simple smart contract. This is a Solidity contract called Simple Adder. It has one function called add. It takes two numbers, A and B, and returns their sum. Nothing complicated here. The key line is return A plus B. When we compile this, that line becomes something much simpler. Here's what it looks like in Yul. Result equals add AB. The add function in Yul maps directly to the add opcode. When the EVM sees this, it knows exactly what to do. For example, simply take two numbers and add them together. If you want to explore all the EVM opcodes, check out the evm.codes website. It's an interactive reference that shows every opcode, its gas cost, what it takes from the stack, and what it returns. We'll be referencing this throughout the series. But how does the EVM actually perform this addition? It uses something called the stack. The stack is a data structure that follows a simple rule: last in, first out. Think of it like a stack of plates. The last plate you put on top is the first one you take off. The EVM uses this stack to store temporary values during execution. You push values on. You perform operations, you get results. Let me show you how this works. Let's trace through add 5, 3. We want to add 5 and 3 together. Step 1. The EVM pushes 5 onto the stack. This uses an opcode called push1. Now the stack has one item, 5. Step 2. The EVM pushes 3 onto the stack. Another push1 opcode. Now the stack has two items. 3 is on top, 5 is below it. Step 3. The EVM executes the add opcode. Add takes the top two items from the stack. It pops off 3, it pops off 5. It adds them together. 3 plus 5 equals 8. Then it pushes the result back onto the stack. Now the stack has one item, 8. That's our answer. The result sits at the top of the stack, ready to be returned. Let's recap what we've learned. The EVM is a decentralized computer that runs on every Ethereum node. Gas is the fuel that powers execution and prevents abuse. There are two compilation pipelines. The legacy pipeline goes straight from Solidity to opcodes. The IR pipeline uses Yul as an intermediate step. We'll use Yul a lot in this series because it shows us exactly what the EVM is doing. And finally, the stack is where all calculations happen. These are the foundational concepts you need to understand the EVM. Everything else builds on top of these ideas. In the next video, we'll dive deeper into the stack. We'll explore more arithmetic operations and see exactly how they manipulate data. Thanks for watching. Subscribe if you enjoyed this video or learned something new. I'll see you in the next one.